There are moments in space travel that only turn out to be turning points years later, and that's exactly the kind of moment we're in right now. Because officially we're talking about lunar landers, hardware, contracts, test flights, and technical architectures. But in reality, something much bigger is happening right now. The entire strategic goal of space travel is shifting again, and this time it's visible. Just a few years ago, the story was clear. Mars was the big goal, and everything was ultimately leading toward a city on Mars. That was the narrative of Elon Musk, of SpaceX, and honestly, also the vision that inspired many space enthusiasts. And now Musk is suddenly publicly saying that the immediate focus is on the moon. Not as a departure from Mars, but as the next realistic step. A kind of way station, a training camp, maybe even an industrial concept. At first, that sounds like a small change in strategy, but it isn't. It's more of a signal. So you could say that Mars hasn't been pushed back, but for the first time has been given a realistic time frame. Because at the same time, National Aeronautics and Space Administration is programmed for manned moon landings, the Human Landing System, or Human Landing System for short, is experiencing new drama. And this drama shows that we're not just seeing a space program right now, but a real industrial race. National Aeronautics and Space Administration originally selected only a single lander, the Starship variant from SpaceX. Because Congress, against its better judgment, didn't want to allocate a budget for a second system. The Starship Human Landing System is a gigantic system. Radically different from anything that has flown before, fully reusable, capable of being refueled in orbit, theoretically extremely cheap per mission, at least on paper. But that creates political pressure and political backlash. The result? A second competitor was added. Blue Origin. The Blue Moon architecture from Blue Origin also received a National Aeronautics and Space Administration contract, but with a significantly different philosophy, more conservative, modular, and built in a classic way. More traditional aerospace thinking, less revolutionary, but evolutionary, still sustainable and reusable. Suddenly, there is no longer just the one lunar lander. Blue Origin's first unnoticed Blue Moon Mark I lander, Endurance, is scheduled to launch toward the moon on a new Glen in the coming weeks and land for the first time. In response to President Trump's space directive, both Blue Origin and SpaceX announced plans to establish an accelerated architecture. There's a race, and here's where the interesting part of this race begins. It doesn't just concern crewed missions. Many of the new concepts can just as well be set up for uncrewed cargo landings, infrastructure, fuel, rovers, and possibly even early industrial facilities. That means the moon is no longer seen just as a symbol, but as a logistical target. And this is exactly where the matter becomes bigger than just National Aeronautics and Space Administration politics. Because while National Aeronautics and Space Administration is trying to develop two competing landing systems in parallel, Musk is publicly talking about something that at first sounds almost absurd. 1 million satellite data centers in space, massive orbital distributed computing power. SpaceX has already submitted an application for this to the United States Communications Authority Federal Communications Commission. If this is serious, and there are many indications that it is, then we're no longer just talking about space travel as exploration. We're talking about infrastructure, and infrastructure always changes everything. Because suddenly, the moon makes strategic sense. Short communication latency relative to Earth, raw materials for fuel production, extreme availability of solar energy, and it's ideal as a logistical hub between Earth, Mars, and deep space. Everything. The vision of a self-growing city on the moon sounds like science fiction at first. But when large AI systems, energy demands, and orbital computing become real, then the moon suddenly becomes an industrial location. And this is where the central question of this video arises. Is the Human Landing System drama really just a competition between two lunar landers, or are we witnessing the beginning of a new space economy? Because while everyone is talking about individual landing missions, the real goal may already be shifting to a new level. When we talk about the current race for lunar landers, we first need to make one thing clear. This is not a classic one. Who is building the best lander competition anymore? It's about something much bigger. It's about architecture, about strategy, about the question of what the next decades of space travel should look like. a game of risk on a solar level, so to speak. Originally, the human landing system was relatively clearly defined, a manned lunar lander that brings astronauts from lunar orbit to the surface and back again, period. But in the meantime, the picture has expanded massively. The new concepts are no longer just vehicles, they are potential infrastructure building blocks. Because on one side, there's an approach that radically focuses on scaling, a gigantic, reusable system that is not only meant to land, but also to establish entire logistics flows to the moon in the long term. On the other side, there's a more traditional approach, modular architecture, gradual growth, and more conservative technology decisions. Officially, both sides are still talking about manned moon landings, but unofficially, the industry has long been discussing something else. Do these systems even need to be permanently manned, or will they first be used as unmanned transports? And that's a crucial shift. Because as soon as a lunar lander can also operate unmanned, it suddenly becomes much more than just a taxi for astronauts. Then it becomes a freighter, an infrastructure supplier, a potential foundation for a permanent presence. And that's exactly in line with a bigger trend that's becoming visible right now. The focus is shifting from symbolic flag planting and footprint thinking to logistics, energy supply, and permanent infrastructure. For a long time, Mars was considered the ultimate goal, a grand vision, an interplanetary colony, a self-sustaining city. But recently, there have been more and more signals that, in the short term, something else has priority. The moon. That might sound contradictory at first, after all. For years it was emphasized that the moon was just a stepping stone. But from a strategic point of view, the shift suddenly makes a surprising amount of sense. The moon is close, communication delays are seconds instead of minutes, supply is possible, and rescue is theoretically realistic. And above all, you can test technologies there that would later be crucial for Mars: fuel production, autonomous construction processes, long-term life support. However, that doesn't mean Mars is off the table. On the contrary, Mars is now getting something it has long been missing: a realistic time frame instead. Soon, a clearer idea will emerge. First infrastructure in cislunar space, then scaling up, then Mars. And this is exactly where one of the most exciting ideas of all begins: the idea of a self-growing lunar city. If you put together the current statements and developments, a possible scenario emerges: not individual missions or landings, but a system that expands itself. One lander brings material, the next brings machines, the next brings energy supply. Then maybe automated construction follows, and after that, permanent habitats. A city doesn't grow all at once. It develops layer by layer. After all, Rome wasn't built in a day either. Mars and moon cities are likely to follow the same axiom. And suddenly, the moon no longer seems like a destination, but rather like an industrial site, a kind of testing ground for what is supposed to happen much farther out later on. And now to this thing with 1 million satellites. At the same time, another idea emerges that sounds almost absurd: extremely large satellite constellations for data centers in space. The idea behind it is surprisingly logical, at least on paper. Data centers consume enormous amounts of energy and generate tremendous heat. In space, permanent solar energy is available, and heat can be dissipated directly through infrared radiation. No cooling water, no local power grids, no land issues. If you think about it further, the moon suddenly takes on a new role as a possible location for energy or industrial hubs that could support such systems. It sounds absolutely futuristic, but many major space developments start exactly like this, as a radical idea that seems absurd at first. For example, think back to the time when Elon Musk asked his engineers to design starships so that they wouldn't need legs, but instead would be caught by a tower. Back then it was radical, but in retrospect it seems like the most sensible way. Another point that changes this discussion is the vision of extremely high launch frequencies, 1 rocket per hour. It sounds almost absurd today, but exactly these kinds of numbers are now circulating among experts as a long-term target. And here's an interesting thought. If a system actually achieves this kind of launch cadence, why isn't Mars already the direct target? The answer probably lies in the risk. Mars needs massive infrastructure before the first crew could really be safe. The moon, on the other hand, allows for iterative development. Mistakes are more manageable, learning happens faster, and supplies can arrive in weeks instead of years. That means the moon might not be a replacement for Mars, but rather an accelerator. Besides, you have to do something with your fleet of hundreds of starships while you're waiting for the Mars transfer window. You can think of it like this. While the moon has the highest priority, every 2 years or so, ships and cargo are still sent to Mars to prepare for the long-term vision. At the same time, we see something else that is rarely considered together: the increasing interconnection of space travel, AI, data infrastructure, and great capital power. When large technology companies start to see space travel not just as a transportation problem, but as an infrastructure problem, the game changes completely. Then suddenly it's about scaling to a completely different level, and that's exactly why the current human landing system feels this way. It's not just about who lands on the moon first, but about which system ultimately becomes the foundation of the next space economy. Although a broadly established transport infrastructure is certainly desirable. If you really want to understand the current human landing system race, you can't just look at individual countries, because the vehicles themselves are actually just symptoms of a much bigger question. What does sustainable space travel even look like? And right now, two philosophies are clashing here. The SpaceX vision relies on maximum scaling. Everything is thought of on a large scale. They focus on radical size and reusability. The idea behind it is simple, but brutally consistent. If you want a permanent presence on the moon, you don't need a small optimized taxi. You need a system that can transport tons of material over and over again. In this logic, the lander is not the goal, but a part of a huge transport chain. It should not only transport crew, but also habitats, machines, fuel, and infrastructure. The same applies to Mars. Starship was never the beginning of the Mars conquest, but rather the catalyst that makes this vision possible in the first place. In short, the moon is treated like a logistical problem. The advantage is obvious. Gigantic payloads of over 100 tons, extremely low cost per transported ton, and, thanks to the rapid and complete reuse of the transporters, extremely scalable in the long term. But the price for this is also clear: enormous technical complexity, high development risks, and dependence on technologies that still need to be proven. It's the all-or-nothing strategy. If it works, it changes everything. If it fails, a lot falls apart all at once. The Blue Origin vision relies on evolution instead of revolution, an approach that seems much more conservative but can also be very strong strategically. This is about modular systems, smaller development steps, and an architecture that uses as many existing technologies as possible. The basic idea is it's better to build a system that works early and can be expanded step by step rather than waiting for a big leap. That may seem less spectacular, but from the perspective of many government programs, it is significantly less risky. The advantages are earlier operational readiness, smaller technological leaps, and more easily plannable certification processes. The disadvantages are poor scalability, higher costs per ton transported, and less long-term growth potential. Basically, we see the same conflict here as in many technology markets: revolution versus evolution. And now there's a development that's almost flying under the radar. The more complex these systems become, the more attractive one thought becomes. Why not use unmanned versions first? An unmanned lander can build infrastructure, test resources, set up fuel depots, and start autonomous construction processes. And above all, it can fail without risking human lives. That changes the entire human landing system narrative. Maybe the first truly important lunar landers aren't even crew vehicles. That's a paradigm shift. Historically, National Aeronautics and Space Administration was often mission-centered. Apollo had a clear goal: getting people to the moon. Today, the focus is increasingly shifting to systems that are meant to work beyond individual missions. In plain terms, this means reusable hardware, permanent infrastructure, and continuous supply chains. This means the moon is becoming less of a prestige target and more of a construction site, and that's exactly why the human landing system wire is so important. No matter which architecture wins, it will lay the foundation for the next decades. This leads to the moon suddenly seeming more important than Mars, a point that many underestimate. The moon is not only scientifically interesting, it has become geopolitically relevant. Several nations are planning a long-term presence there. And whoever establishes functioning infrastructure first gains experience, sets standards, and gains influence. At least that's the diplomatic view. In reality, it's about control and power. China doesn't trust the West, and the same is true the other way around. And here's the irony. Of all things, the goal that was considered old news for decades is suddenly becoming the central stage of space exploration. While everyone dreams of Mars, the truly crucial systems are probably being developed much closer to Earth. And that's exactly why the Human Landing System program is more than just another one. It's a testing ground for the next space economy. And this is exactly where a short, rather nerdy digression fits in. Because while we're talking about gigantic lunar landers and infrastructure here, we've once again done something very hands-on in the studio. We printed a new Starship model, complete with super heavy booster, and of course it was made using the Core 1 3D printer from Prusa. The thing looks so good that we asked ourselves, wouldn't this actually be something you would be interested in? Honestly, we're currently considering whether we should offer such models in our shop, but before we decide anything, we want to hear your opinion. What would you prefer? A fully assembled model that can go straight on the shelf, or a kit that you assemble yourself? And most importantly, what would you realistically pay for it? So, once for the kit, and once for a fully assembled version, please be sure to write that in the comments. That helps us a lot with our assessment. I've linked the printer and the model for you below. And now, back to the main topic. When you put all the pieces of the puzzle together, the current human landing system drama suddenly doesn't seem like an argument about lunar landers anymore. It's actually a discussion about the future of space travel as a whole. And that's exactly why it's worth taking a step back, because we're witnessing a shift that hardly anyone is openly talking about. The moon is no longer just a destination, it's becoming infrastructure. Apollo was a sprint, Artemis is a construction project. The difference could hardly be greater. Back then, it was about landing once and coming back. Today, it's about creating something that lasts. Permanent logistics, supply chains, reusable transporters, energy production, possibly even industry. And that's exactly why the type of vehicles is changing. Many people are wondering, why is everyone suddenly talking so much about the moon, even though Mars was always the big goal? The answer is brutally pragmatic. The moon is only a few days away, relatively easy to reach, logistically controllable, and ideal as a testing ground for technologies. Anyone who can learn how to operate permanently outside of Earth, that drastically reduces the risk for later Mars missions. So the moon is not a substitute for Mars, it's the dress rehearsal. And now comes an aspect that many underestimate. Massive satellite networks are changing the rules of the game. When millions of satellites are created in orbit for communication, AI computing power, or industrial use, a new kind of infrastructure is emerging in space. That means constant demand for transportation, maintenance, material supplies, and energy. And suddenly, a lunar outpost makes sense, not just as a scientific base, but as part of a larger orbital economic system. At first, the idea sounds futuristic, data centers in space. But when you look at the energy consumption of modern AI systems, it becomes clear why these ideas are emerging. Unlimited solar energy, passive cooling from space, and direct connection to global satellite networks. By the way, I've produced 2 videos on this topic, which you can find linked below. Whether this is realistic in the short term is another question. But the very fact that such concepts are being seriously discussed once again shows that space travel is shifting from exploration to infrastructure. And what does that mean for Mars? Here comes perhaps the most important point of the whole video. Mars hasn't disappeared, it's just been given a more realistic time horizon. Because if we're being honest, the biggest opponent of the Mars plan was never the technology. It was the logistics. This logistics will now be established first on the moon. So you could say the moon is the place where we learn to operate an extraterrestrial civilization. Only when that works will Mars really become realistic. Artemis is explicitly planning to bring people to the moon and stay there permanently. Nevertheless, in the long term, there must be a direct economic benefit, which was found with the orbital data centers. National Aeronautics and Space Administration launched Artemis. But they didn't have a long-term plan. They were exactly hoping that the private sector would come up with a solution to this problem. Now, this big question arises. If Starship can fly so quickly and frequently, why not go straight to Mars? You often hear this question when a system could theoretically achieve extremely high launch rates. Why not just go straight away? Because speed alone doesn't replace an ecosystem? You need production, fuel supply chains, maintenance, and experience with long-term operations, and that's exactly what the moon provides. It's not the final destination, it's the training ground. And just because the main focus is on the moon doesn't mean we won't go to Mars at all. While the lunar base is being built, starships will definitely be sent to Mars, but not with the brute force that was announced, rather in a more mature way. They will gradually begin to prepare for the stay of the first cruise, and this brings everything full circle. The human landing system drama seems chaotic because we are in the middle of a transition. Old spaceflight logic meets new scaling models, government programs meet private mega strategies, and missions become infrastructure. The competition between different landing architectures is therefore not only technically exciting, it will determine what the next decades in space will look like. Perhaps we are currently witnessing the most important change since Apollo, not because we are returning to the moon, but because we are beginning to use it. And if that works, then everything changes. Mars becomes more realistic, large-scale space travel becomes economically conceivable, and space slowly shifts from being a destination to becoming a place. My name is Serwan, and this was Mars Chronicles. Thank you for tuning in. Per aspera ad astra.